Predicting ionic formulae. Although an ionic compound is made up of oppositely charged ions, its overall charge must always be zero. That means in an ionic compound, the total number of positive charges must equal the total number of negative charges. So let's look at an example of how we can write the ionic formulae for a compound. Let's do sodium chloride. Now sodium is in group 1. So that means the charge on the sodium ion will be +1. Chlorine is in group 7. So the chloride ion will have a charge of -1. Now, in an ionic compound, the number of positive charges must equal the number of negative charges. So for every positive sodium, there must be a negative chloride. So the formula for sodium chloride is NaCl. Another way of coming up with the formula is using what we call the crossover method, where you draw an arrow from the sodium to underneath the chloride. Write down the number of charges the sodium has. The sodium has 1 charge. The chloride has 1 charge. And that gives you the ratio. The ratio of the sodium ions to the chloride ions is 1 to 1. That gives you the formula for sodium chloride. Another ionic compound is magnesium chloride. Now magnesium is in group 2. So the magnesium ion will have a charge of +2. Chlorine, as we've just seen, is in group 7, so it'll have a charge of -1. So using that crossover method, chloride has 1 charge. The ratio of magnesium ions to chloride ions is 1 to 2. What that means is, because the magnesium has 2 positive charges, the ionic compound must contain 2 chloride ions for every single magnesium ion. And that gives us a total charge of 0. So the formula for magnesium chloride is MgCl2. Another example we can use is calcium oxide. Calcium is a metal in group 2, so it will have a charge of +2. Oxygen is in group 6, so the oxide ion will have a charge of -2. If we use the crossover method like before, we actually get a ratio of 2 to 2. Now, when it comes to these ratios of ions, we have to use the smallest numbers possible. So a simpler version of 2 to 2 is the ratio 1 to 1. So that tells us that the formula for calcium oxide is CaO. Another ionic compound could be aluminium oxide. So aluminium is in group 3. We'll have means the aluminium ion will have a charge of +3. As we've just seen, oxygen in group 6 has got a charge of -2. So the ionic compound must have an overall charge of 0. So if we use a crossover method, that tells us that the ratio is 2 to 3. What this means is in aluminium oxide, if we have 2 aluminium ions, we must have 3 oxide ions. As you can see over this side, we have a total positive charge of 6 positives. The oxides give us 6 negatives. These charges cancel each other out. So that means that the formula for aluminium oxide must be Al2O3. Now let's have a look at some ionic compounds that contain molecular ions. So for example, sodium hydroxide. Now sodium does contain the sodium ion, as we've seen before, but it also contains a molecular ion. That's an ion that contains more than one element. And that's a hydroxide ion. So bearing in mind that ionic compounds must have an overall charge of 0, if we've got one positive on the sodium, we need one negative charge to cancel it out. So the formula must be NaOH. And again, using the crossover method, you can get the ratio, because sodium has got one charge. The hydroxide has one charge. So therefore the ratio is 1 to 1, which will give us the formula NaOH. Another ionic compound is calcium hydroxide. So calcium, as we've seen before, is in group 2, so it will have a charge of +2. Hydroxide, -1. Let's use the crossover method. The hydroxide has got one charge. What this tells us is that the ratio of calcium to hydroxide is 1 to 2. So what that means is that if we have one calcium ion, we need two hydroxides to cancel out the two positives. So the formula for calcium hydroxide is this. Now the brackets show us that we have got two hydroxide ions for each single calcium ion. These brackets are important. If the bracket wasn't there, the formula would be this. Now this is incorrect because this tells us that calcium hydroxide has got one calcium, one oxygen, and two hydrogens. In reality, calcium hydroxide has got one calcium, two oxygens, and two hydrogens. This is incorrect. So we use the brackets to avoid any confusion.